Welcome or welcome back at C Squared. In this lesson we will talk about congruence, but we're gonna talk about right triangles congruence. And I said here there are 4 different ways to prove right triangles congruence, and the first one is what we call leg-leg congruence theorem, which says if the legs of one right triangle are congruent to the corresponding legs of another triangle, then the triangles are congruent. So let's take a look in this picture. We see these AB congruent to the E, these 2 legs are congruent, and these 2 legs are congruent. Then the triangle ABC congruent to triangle DEF. Okay. And if you take a look, you can kind of say this one is like a side congruence theorem, because the angle included is a 90-degree angle. But we call this one leg-leg congruence theorem. A second way to prove that the right triangles are congruent, the right triangle congruence, is what we call hypotenuse-angle, or HA. If the hypotenuse and an acute angle, we have 2 acute angles in a right triangle, of one right triangle are congruent to the corresponding hypotenuse and acute angle of another right triangle, then the triangles are congruent. Let's see the picture. And we notice here we have AC congruent to DF. These are the hypotenuse of these 2 right triangles. They are congruent. And we notice angle C and angle F are congruent. They are marked the same. So based on this hypotenuse angle, these 2 triangles, triangle ABC and triangle DEF, are congruent based on hypotenuse angle congruence theorem. The third way is what we called leg angle congruence theorem. And you see here, if one leg and an acute angle, one of the acute angles of the right triangle, are congruent to the leg and an acute angle of another right triangle, then the triangles are congruent. And this is the picture. We notice AB congruent to DE. These are the 2 legs, the corresponding congruent 2 legs, and these are the 2 angles that are also congruent. Then the triangles are congruent. If you want to say this one looks like an angle side congruence theorem, I mentioned the first one, and the second one. The second one looks for me like an also angle side congruence theorem, if you think about the previous lessons. Okay, so that is the third way, and there is a fourth way, which is called Hypotenuse-Leg congruence theorem. If the hypotenuse and one leg of one right triangle are congruent to the corresponding hypotenuse and one leg of another right triangle, then the triangles are congruent. And this is the picture. Let's see what I meant. Look at here, the hypotenuse AC and DF are congruent. The legs AB and DE are congruent, then the 2 triangles are congruent. This is the hypotenuse-leg theorem. And this one is a very interesting one. There is no such thing like side-side angle, but using Pythagorean theorem we can translate this one to a side-side congruence postulate. Okay, but again, since these are right triangle, this is what we call hypotenuse-leg. So now let's see some example. In this example here, we need to determine whether each pair of the triangles are congruent. If those 2 triangles are congruent, then write the congruence statement and include the theorem that applies. So let's take a look to this part A. We notice we have here these 2 legs congruent. They are marked the same, and they are legs, and these 2 legs are congruent, right? So I can write here AB, segment AB congruent with segment MT, BC congruent with MN. So these are the 2 legs. So then by what? By leg congruence criteria, let me put it here, by leg congruence criteria, because we're talking about two right triangle. Triangle ABC congruent to what? Triangle. Now we very careful, match the things. A goes with T, B goes with M, obviously that's the easy part, and C goes with N. Okay, so this is part A. Let's take a look to part B. We have these two right triangles. What do you notice here? We have these two parts congruent, and these two are hypotenuse, and these two angles. So I think this one what is called hypotenuse-angle congruence theorem. So let's write this GF, segment GF congruent to segment LK, angle G congruent to angle K, therefore by hypotenuse angle triangle FHG, let's say like that, FHG congruent to what? Now the second one, you know, has to be, you have to be very careful and write the corresponding letter. The corresponding letter for F will be L, for H is the easy part, R, and obviously for G is going to be the last one, K. Okay, so triangle FHG congruent to triangle LRK. We'll see another example here, and let's see if these triangles are congruent. So on part A, we notice we have these two parts congruent, these are legs, and these two parts are congruent, these are angles. So we have what is called leg angle congruence theorem. Let's put that here down. So we have TS congruent with FP, angle V congruent to angle L, by, I said, leg angle congruence theorem, triangle VTS is congruent with triangle, and now very important, start with the corresponding letter. Corresponding letter for V is L, then for T it's P, and for S obviously is the last one, F. So triangle VTX congruent with triangle LPF. Let's take a look to part B in this example, and we notice these two parts are congruent. These are the hypotenuse, and these two parts are congruent. They are marked the same. So this is going to be a hypotenuse-leg theorem, congruence theorem for this right triangle. So we have NC congruent with BW, then we have NH congruent to WZ. So by hypotenuse-leg congruence theorem, triangle NHC congruent with triangle WZB. Okay. In some cases, I said here, the right triangles share common parts, like in these two examples I have here, A and B. Let's say if these triangles are congruent, obviously we can see there are only two triangles in each picture, very similar with the previous problem. So we're looking here, we have AB, which is a leg in the triangle ABC, and DC, which is a leg in the triangle ADC, are congruent, and also the common part is this guy, the hypotenuse. So this one is going to be a hypotenuse-leg congruence theorem. So I'm going to write here AC, it's congruent to itself. If you remember, that is called the reflexive property. Then AB congruent with DC. So by hypotenuse-leg, these two triangle ABC congruent with, and now again we want to match the corresponding letter CDA. So very important to write the corresponding things, the congruence triangles. Let's take a look to part B. We notice we have these two parts congruent. These are the two legs of this right triangle, and we have a common part, this leg here. So very similar to the other one. However, the theorem is going to be leg-leg. So we have HF congruent with itself, HF. So these are legs. EF congruent with FG. These are also legs. So by leg, we have these two triangle congruent. Triangle HFE, let's say you do it this way, congruent to triangle HFG. Let's see also this example. Again, we notice they share a common side in both things, this hypotenuse. But also now I want you to take a look to something. This here means AB and DC are parallel line. AB and BC are parallel segment, let's be sure, right? Okay, which means these two angles are congruent because they're alternate interior angles. So we have those two angles congruent, and we have this hypotenuse as a common side. So this is going to be hypotenuse angle. So let's see how we write that. AC congruent to itself, the common part, right? And then the angle, and here we have to use three letters, right? BAC congruent to angle DCA. And by the way, if you need to write the proof, you need to write this reason. And I said these are alternate interior angles. So this is going to be by hypotenuse angle congruence theorem. So then we have triangle ABC congruent to triangle CDA. Let's go to part B. We notice these two angles are congruent. They mark the same. This is a common side, the common leg. So this is going to be leg angle congruence theorem. So I'm going to start with HF congruence with itself, the reflexive property. Very important to remember this name, especially when you write proof. And then angle EHF congruent to angle GHF. Then by leg angle congruence theorem, triangle HFE congruent to triangle HFG. In the last part of this lesson, we'll do some proofs. We're going to do some two-column proofs and a flowchart. I'm going to try to show each one. So on this problem, we said we need to write the 2-column proofs, which I'm going to do it. And you can try the flowchart. And one is given: angle M and angle N are right angles. So I'm going to mark them here. Sometimes they are marked for you, sometimes they are not. But now I can mark them. So we talk about 2 right triangles, right? These 2 triangles we have to prove that are congruent, they are right triangle. And TR bisect MTN. So that means these 2 angles are congruent, right? So an angle bisector, that is what TR is, cut the angle in half. And we notice these common sides. So my thinking here is I'm going to have an hypotenuse angle, right? The hypotenuse, the common side, and the angles are the one you see in the picture formed by the angle bisector. So now I know what I need to do. Let's do the 2-column proofs. On the first column we put statements, and on the second column we put reason. Let me do that line a little bit better. I think I can do that. And again, reasons. And you always start with what is given. So we get angle M and angle N right angles. And this is given. Let me draw a line here because I use 2 rows, right? Based on this statement, we can say triangle MRT and triangle NRT are right triangle. So that will be definition of right triangles. Triangles that have right angles. Okay, I cannot put the S there. Okay, so this is the second row. And now, knowing these 2 triangles are right triangle, we can use one of the 4. And you see, I said hypotenuse angle. So let's start with TR, the hypotenuse, congruent to itself, TR. If you remember, I call this property reflexive property. In fact, to be correct, is reflexive property of congruency. Then I'm going to grab this one right here, TR bisect angle MTN, and this is given to us. And you see this given is right here down. Okay, so sometimes that's the case. Okay, and by the way, you could have started with this first statement instead of angle M and N right angles. You could have switched these statements. Okay, so TR bisect angle MTN, this is given, and based on this statement we have the next statement, which is angle MTR congruent with angle NTR. And why was the reason? Definition of angle bisector. Okay, so an angle bisector cuts an angle in half. Okay, so now we list what we're supposed to list. These hypotenuse, right? If you need to know, this is the hypotenuse and this is the angle, right? So if that you think helps you, put it there, and you know now it's an hypotenuse angle. So now I can really finish this proof. Triangle MRT congruent with triangle NRT. This is the last statement. You finish always with this one. And by what? by hypotenuse-angle congruence theorem. We don't really need these two guys here. Let's move to the next problem. Another two column proofs or a flowchart. Here I'm going to do a flowchart. We have here AD perpendicular on BC, and we have here this angle will be a right angle, and basically the other angle, this one, will be also a right angle, but we don't need to mark them both. So we have two right triangles. That's the point here. And then AB bisect BC, so that means these two guys are congruent. And we have this common side, which is a leg in both right triangles. So this will be a leg-leg. Okay, so now again I'm going to do a flow chart, and I'm going to start to what is given. AD perpendicular on BC. Let's start with the first one. This is given. Okay, let me write the given first. Based on this, we have those two right angles, and you want to say angle ADB and angle ADC, right angles. And what's the reason for this? I mean, obviously it's the definition of perpendicular lines, right? Perpendicular line. So that means perpendiculars, just to be sure. Based on this statement, I'm going to write another statement, which is triangle ABD. Oops, I should have started with A. And triangle ACD, a right triangle. Okay, so you really want to do this first part, because then you can use one of the four, right? But what's the reason here? Definition of right triangle, right? Right triangles have right angles. Okay, so now we can go and write the next statement, which is AD bisect BC. So let's be sure AD bisect segment AD bisect segment BC. This is given. Based on this statement, we can write BD, segment BD congruent of segment DC. And this is definition of perpendicular bisector, we can say here. Okay, and this will be one of the legs. So if you want to put like this, okay, so we cover the legs. And then we have one more leg, right? A common leg, AD congruent to itself, AD. And if you remember, that is what we call the reflexive property. That is the reason. And now, based on this statement, and yes, this one also, because it doesn't work if they are no right triangle, we can say these two triangles are congruent. The last statement, triangle ABD congruent to triangle ACD by leg. Okay, and that is the flowchart for this problem. But again, I would suggest you first to do this one where you prove you have right triangles, and then you can do what I did here, leg, okay? Theorem congruence. And a last example in this lesson is this one, right? A two-column proof or a flowchart. Okay, so I'm gonna do again a flowchart. But let's take a look here first what we have. CD perpendicular on AB. So this means it's a right triangle because this is a right angle, and this very similar. So we have these two triangular right triangles. So we're looking for one of the four, and we notice here we have AD, which is this segment, and AE are congruent, this segment, these parts of the big segment AB. But also they have a common, this is a common angle. So this will be a leg angle from what I see. And if you do not see it, you may want to redraw the triangle. I'm going to try to do a decent job here. Okay, so we have this, this is a right angle, and this is the congruent angle, and the other triangle is very similar. Let me see if I can do it. Something like this, right? Okay, so if we remove those two triangles, we get these two corresponding congruent parts, these two corresponding congruent angles, the right angle. So that will be a leg angle based on what I see. So now I can do the let's do a flowchart to have another example. So we're going to start with CD perpendicular on AB, and we can separate these two statements, the first two statement if you want. Let's see how that looks. This is given. From this one, if you remember, we can say angle ADC, it's a right angle. And the reason, definition of perpendicular line. From this thing that we have a right angle, we can say the triangle ADC, it's a right triangle. So we really want to mention this in the proof. Right triangle. And the reason is very simple. This is the definition of a right triangle. It has a right angle. And let's go, and very similar we're gonna take this statement, the second given statement, we're gonna do the same thing. BE, segment BE, perpendicular on AC. And this is given. And then we say angle BEA, it's a right angle. And this is what? Definition of perpendicular lines, if you remember, right? And then we mentioned the second triangle, the one that we need to prove they are congruent with the other one. Triangle AEB, I'm sorry, is a right triangle. And again, here, very similar. This is the fact that is a definition of a right angle, a triangle that has a right angle. So again, I think you should do this part, because then you can use one of the four. Which one? I said leg angle. So my first thing will be now the last part, which is the easier, I think the easiest part. AD, if you notice, right? AD congruent to AE, and that is given also. let's hope I have enough place here. Yeah, I think I have, because I can just call it angle A, congruent with angle A, right? This is the angle A in both triangles. We can use just one letter because it's the only one. And that will be, if you remember what we call that reflexive property, right? So now we have everything we need. Okay, we know these two triangles are right triangles. We know these two legs are congruent. We know this is a common angle, they are congruent. So we can go to the last thing, triangle ADC. Congruent with triangle AEB. And by what? By what? By what? It's by leg angle congruence theorem. Okay, and that's it for today's lesson. If you enjoyed the lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.